Hello everyone, my name is Facundo and today we will talk about incremental static regeneration. First of all, I want to introduce myself. I'm Facundo Giuliani from Buenos Aires, Argentina. I'm a developer relations engineer at Storyblok. I'm also an Auth0 ambassador, a Prisma ambassador, and a Cloudinary media developer expert. If you want to talk about any of these services or tools, or if you want to talk about any other thing, you can contact me. My website is fgiuliani.com and I'm on Twitter. My handle is Facundo Zurdo. So first of all, I wanted to define what a static web page is. It is a web page that is delivered to the user's browser exactly as it's stored. So we can have a web page that has an HTML file, CSS file, and JavaScript file that we will call it static page if we are delivering the same files to all the users that visit our website, no matter any condition. This doesn't mean that the content of the page is going to be static. I mean, we can have interactions and dynamism, but we will use that, or we will generate this using JavaScript. But the files that we are going to deliver to all the users that are visiting our website will be the same. Different is the case of the dynamic web pages, which are web pages where some of the content is generated dynamically when needed. So depending on the user that is visiting our website or other conditions, we will generate HTML content dynamically on the fly, and we will return that to the user as if it were an HTML page that was statically stored on the website. The user won't know that. We have two main methods of rendering this dynamically generated HTML content. One of these methods is the server-side rendering, where the HTML content is generated by the web server and returned to the user as if it were a HTML file. But on the other hand, we have the client-side rendering, where the HTML content is rendered directly in the browser using JavaScript. So this will be the example of a React application, for instance, where we have JavaScript code being executed in the user's browser and generating HTML content dynamically. So we can choose these types of rendering HTML content if we want to generate it dynamically, let's say. But let's go back to the static web page, because even though this was the first type of web pages that we were able to create on the 90s, for instance, they have some cool benefits that we can identify and that we can get advantage of even in these times, in these years. For instance, a static web page is fast because we are delivering static assets to the users without doing any kind of processing or any dynamic generation of content. The static web pages are cheap because we will need websites that, web servers that will store these static assets and deliver them to the users without doing any process, or we don't need any calculus to be executed. So they can only store the files and deliver them to the users that are visiting our websites. The static web pages are easier to maintain because as any other file system, we can move files from one side to the other. They are more secure because we are not executing code on the fly, so we don't have to worry about securing any kind of code execution. They are easy to scale because adding more storage space to our web servers, we will be able to scale the static websites that we are working on. So for instance, if we have a blog and we are creating more and more articles and blog posts in our website, just adding more storage space to the web server will help us to scale our website. And they are stable because as we are not executing code or doing operations on the fly, the visitors will only have to download the files to their browsers and will browse the website. So that will make our website to work more stable. So having all these benefits in mind, a new concept was created, the concept of static site generation, which is compiling and rendering a web application at build time, generating static assets like HTML, JavaScript, and CSS files. So we will have a project with a templating engine. Depending on the programming language that we want to use, we can have different templates that we can use. And besides these templates, we will have data sources like APIs that we can consume, headless CMSs or content management systems. We can have databases, we can have processes that are being executed, and based on these operations and these data sources and these templates, we will run a build process using a static site generator, and we will generate static assets that are going to be my website, my static website. So we can work with different tools, modern tools, to create our projects and our websites and generate static assets as if it were a static site, like the ones that we created in the 90s, as I said. So there are different static site generators that we can use, and there are a lot of options in the market depending on the framework or the programming language that you want to use. Today I will focus on Next.js, which is a React framework that allows creating user interfaces, static pages, and server-side rendered pages. So we can create different pages using React components and all the features that React offers us. And Next.js offers a page-based way of working. So we will have one JavaScript file per page in our website, or we can work with dynamic routes that one JavaScript file will generate multiple pages. Like for instance, we can create one JavaScript file with Next.js code to generate all the blog posts that we can have in our blog site. And we can use static site generation to generate all these static assets at build time. So we will have all the blog generated, and it will be all static assets like HTML files, JavaScript files, and CSS files, and we can deploy that to the web server. So we will have our website using static assets, but we created it using JavaScript and a React framework like Next.js. What is cool about Next.js is that it also offers other types of rendering and generating HTML content, like server-side rendering or client-side rendering, as we mentioned before. And it also offers API routes that we can use as serverless functions, for instance, to execute an API, an operation, and return information to our pages that we can use to render HTML content. And it also has a fast refresh on developed environment. So if we are working locally and we are working with the static site generation mode, we don't have to wait to generate the static asset whenever we are making or applying a change to our code. We will have it automatically updated in our browser while we are working. Another cool thing that Next.js offers is that we can work with the different types of rendering in a page level. So we can have some pages that are generated at build time using static site generation, and other pages that can be generated using server-side rendering or client-side rendering, all living in the same project, in the same website. So for instance, in the case of the blog, we can create the home page and probably the latest 10 blog posts at build time as a static pages, and we can have the older blog posts that probably will be visited by less users to be generated using server-side rendering or client-side rendering. If we want to offer the same experience in all the blog posts that we have in our website or our blog site, we can generate all of them using static site generator at build time. But here comes a problem, because the process of generating the static assets takes some time. And if our website is getting bigger and bigger with more and more pages, this build time will increase more and more. So in the case that we want to add a new blog post to our platform, or in the case that we want to edit one page to our website, if we want to generate all the static assets at build time, this process will take longer and longer. And besides that, there is a concept that is called atomic deployment, which means that if we are using static site generation, we have to generate all the static assets that we need at build time without errors. If there's any error in the middle of the process, or if there's a page that we are not generating statically, we will roll back all the process and we won't deploy this version of the website. This is done so we don't break the compatibility between the different pages, and we don't have different pages or different versions of the pages living at the same time. So we have our blog, or for example our e-commerce platform, and we are increasing more and more products to the e-commerce platform, and we are building the whole website whenever we add a new product or whenever we change something related to a product. And this build time is getting longer and longer and longer, and that's something that probably won't work for our scenario. So to solve this problem, Next.js now offers a new feature, which is called Incremental Static Regeneration. This feature enables developers to use static site generation on a per-page basis without having to rebuild the entire site. So we will have the build process of the static site generator running for the first time, and we will generate the version 1 of our pages, let's say. After we generate all the pages that we need, we will deploy them to the web server, and we will cache the first version of these pages. We will have a property called vee-validate that we can set in a seconds value. So we can set, for instance, 60 seconds. In that period of time, all the users that visit our website will see the version that is cached of the pages, the first version. But if a visitor comes to our website and wants to visit a certain page after this vee-validate time, Next.js will display the version 1 of the page, the one that is cached, but in the background will execute a build process to regenerate only this page in the background, generate a new version, and after that deploy that to the web server and cache this version. So all the following users that will visit this page will see this version 2 of the page. So in case that we are editing the content of this page, or we fix the typo, or we are adding some more content to the page, this is a cool feature because we don't need to reveal the complete site. We will have this vee-validate time to work for us and to generate the new version of the page when we need it. So this offers us, or this allows us to have faster builds, because in case that we want to generate just a set of static pages, or we can work with a higher cache, so we can cache all the static assets of our website and generate all of them at build time, and after that generate one page at a time when it's needed, just when it's needed. This is cool that we can link this property to a headless CMS, so in case that we have a team of content editors working on our blog post, for instance, or the content of our website, and they are making changes, We don't have to run the build process whenever they apply a new change or whenever they create new content. We will just run the build process per page and when needed. I mean, when a visitor comes to our website after this revalidate time. One other thing that incremental static regeneration offers is that the pages that are generated are persisted between deployments. So if we deploy new version of our website, we will persist the pages that we generated before using incremental static regeneration. This is a problem that we have to evaluate because we are breaking the atomic deployment doing this. I mean, we will have pages of different versions living at the same time. But probably this is something that can help and we can solve a certain scenario using incremental static regeneration. I will show you a quick demo so you can see how each one of these rendering methods works. So what I'm going to do is go to this project, this page that I created, a title and 3 features. We can see that I'm using a Next.js application that is running locally in my computer, and I'm having the same content, which will return the same page using 3 different methods of rendering: server-side rendering, static site generation, and incremental static regeneration. So we can see that this page is using server-side rendering, which is the content. This content is generated for every visitor that we will have in our website. I mean, every user that comes to our website, we will execute the code to generate the HTML content for them. Besides that, we will have the static site generation method, where we have here the same content, but this was generated at build time, when I run a build process at the beginning to generate the static assets. With this example, probably you can see the benefit, but this page will load faster because we are not rendering any content on the fly like we did with the server-side rendering. And finally, we will display incremental static regeneration, where this page was generated at build time also, but if we run it again, we have the revalidate feature running, but again, as I didn't change any content, you can't see any change here. What I'm going to do now is show you the code of my application. This is a Next.js project. I don't want to go super deep into the folder structure of Next.js and how Next.js works, but this is the boilerplate that Next.js generates when we execute create next app using npm in our local computer. So what we have here is a pages folder, and each one of these is the URL that we were visiting in the example that I just displayed, and these ones are JavaScript files, you can see, with dynamic routes. We are using the slugs for the dynamic routes. So what we are doing in this particular case is for server-side rendering. We have the main function here, which is the one that generates the markup for our pages. We have some React components here that are using some story that comes from our headless CMS, which in this case is a Storyblok, and I will show you Storyblok in a couple of minutes. And we are bringing information from the headless CMS to render it on the page. So we have this main function that will generate the markup, and we have a get server-side props function that is executed whenever a user visits our website. So in this code, what we are doing is setting a slug variable with the home value because we are going to bring all the information related to the home page, and well, setting some parameters that we will send to the headless CMS, and using the Storyblok client to get all the information related to that story. One story in Storyblok is like a page, let's say. So we are bringing all the data, all the content for that page. We are returning that as a story, and this return is going to the main function and using the story that we are sending to generate the content related to that story. We will execute this function for every user that visits our website. On the other hand, the static site generation version of the page is using the same main function. You can see that it's exactly the same, but we have a get static props method or function that is executed at build time when we run the static site generation process. You can see that we are doing something very similar here. We are bringing all the data related to a certain story using the Storyblok client, and we return that to the main function. But the thing is, how do we identify which pages we want to render at build time? So to do that, Next.js offers another function which is called get static paths. So what we are doing here is defining the logic that will generate the list of paths of pages that we want to generate at build time and generate the static assets related to them. As my project has only one page, which is the home page, we are sending like a list of paths, but with only one value, which is home. So with this list, we execute the get static props function for every value of this list, and we will generate the markup. Finally, the incremental static regeneration page is the main function is exactly the same, and you will see that is very similar to the one of the static site generation. Here we are doing exactly the same, and here is very similar. But we are setting this property fallback to blocking, and we are adding the vee-validate value that we saw before in the slide, and we are setting that to 10 seconds. So when a user visits our website after 10 seconds, we'll run the build process in the background to generate a new version of the page. So let's see in this example what happens if I edit the content of the page. So let's go to Storyblok, which is the headless CMS, and you can see that, well, Storyblok offers a visual editor, a real-time visual editor that we can use to using the code of our application. You can see that it's pointing to my local host. We can on the fly do some changes and see how it's going to look like. So I can change this feature test, and we can see that how it's going to look like without applying any change to the real content that we are consuming in our production instance, for instance. But if I click on save, we are applying these changes to the draft version of our stories or the content of our page, of our website. So we have all the features that say now feature test. So I will go back to my example, and I will first render the server-side rendering page. What is happening? We are displaying the new content because we are rendering this content for each time a user visits our web page. But on the other hand, if I use static site generation, we will see that we are seeing the old content because this page was generated at build time, and I didn't run the build process again. So we have the version that was generated before as a static asset. So we don't notice that a change was applied to the content of the page. Using incremental static regeneration, we will see that we are displaying the old content that was generated at build time. I mean, like if it weren't edited or updated, but on the background we are executing a build process just for this page. So this visitor won't notice the changes or will see the old version of the page, but if I refresh the page here, I will see the new content, and I'm seeing the version 2 of the page, let's say, and this will happen for all the following users that visit this web page. always considering the revalidate property and the value of this property that we set in the code of our application. So with this demo, I hope it's now clear for you how incremental static regeneration works. If you want to learn more about it, you can go to the Next.js official website. They have an e-commerce platform demo that you can take a look using incremental static regeneration. Or if you want to learn more about Next.js, they have a really cool learning platform that you can follow and learn other features from this very cool framework. So thank you very much. I hope you enjoyed the talk and see you there. Bye.